Welcome back to this wonderful journey through geometry with Coach Maxwell. So as we look at this, we've been on this unit for trig and we started this up. Well, tonight we're going to start looking at solving right triangle problems involving angles of elevation and angles of depression, okay? So we've been looking at solving right triangle problems with just straight trig. Well, now we're going to get to some applications problems, some word problems. So we have to figure out, well, angles of elevation, angles of depression. Now, first of all, the thing you've got to look at is the two words, okay? We've got elevation and depression. Well, both of these are going to originate from a horizontal line. So we know in any problem that we look at, there are always two parallel lines that exist. One of them is usually the ground for our problems. One's going to be the ground. The other one is going to be line of sight in the air. Now, it may be you looking straight out across the meadow or something. It may be you in an airplane looking straight out in the front of the plane. It may be you standing on top of a water tower looking straight out. Well, you've got that one that's parallel to the ground. Then we've got one that's ground level or water level or whatever that is. So those are our two horizontal lines. Well, angles of elevation, angles of depression both originate from a horizontal line. Now, the difference is angle of elevation goes up. So when we look at these, well, obviously there's my right angles. So we've got a couple of angles here. We've got A, there's B, there's C, there's D. So if we start looking for an angle of elevation, it's an angle that starts at a horizontal line and goes up from a horizontal line. Well, A, if we look at A, how's it? From a horizontal line, it goes from here, it goes down. That's not it. D, well, this is a diagonal line. This is vertical. D is neither an angle of elevation, angle of depression. Can't be that. B, well, let's see. It originates from this diagonal line. That's not horizontal. And this vertical line. So B is neither an angle of elevation, angle of depression. C, well, we could say it goes from this horizontal line and it goes up from there. So if we look at that, this is an angle of elevation. And A up here is an angle of depression. So when we start hearing those terms, that's the difference. An angle of depression starts from a horizontal line and goes down. Angle of elevation starts from a horizontal line and goes up. So obviously from this angle of elevation, we can see this is the opposite. That diagonal is the hypotenuse. It's the hypotenuse for both of them. This is our adjacent here. From this angle of depression, here is the opposite. Here is the adjacent. And notice this, if we look at this in terms of a rectangle, the opposite on both sides are congruent. The height on one side is the same as the height on the other. And the adjacent is congruent as well. So if you look at these problems, that's kind of what we're going through. So let's look at some word problems. Let's examine a couple of these and let's see what we can do. So here's the first one. Leah wants to see a castle in an amusement park. She sights the top of the castle at an angle of elevation of 38 degrees. So the first and most important thing is you've got to draw you a picture to be able to see these, okay? Don't just sketch you a little triangle. Sketch this out. Now, I am by no means a great artist, but we'll turn around and attempt it. So there's a line of sight. She's looking at the top here. It says the angle of elevation is 38 degrees. So this angle right here is 38 degrees. I've got this. So when I turn around and look at this, this is a right angle right here. Okay. She knows from her book that the castle is 190 feet tall. Okay, so this whole thing over here is 190 feet. So I guess she got one of those Burn Mom books or something. Leah is 5.5 feet tall. Okay, so Leah over here, she's 5.5 feet tall. How far is she from the castle to the nearest 100? So this is what I want to find. So when we look at this, let's look and see what we've got. Well, we know the height over here of the castle. We know the height of Leah. Well, Leah's height doesn't form our triangle for us. The height of the castle doesn't. Well, it kind of does, but we got to take away Leah's 5.5 feet. So how tall is this side over here? Well, 190 minus 5.5 means we've got 184.5 feet. There's our side. So we know this is opposite. That's our opposite. We're asked to find this side here, which is adjacent. So we're dealing with tangent. So tangent of 38 degrees is equal to the opposite, which is 184.5 over the adjacent, which is what we want to know. All right, so we got a word problem. Tangent 38, that's just a number, big, long, ugly decimal. We know that. 184.5 over x. We've got a fraction with a variable in it. We know we are going to multiply by the denominator to solve it. So let's multiply both sides by x. We now have x times tangent 38 degrees equals 184.5. Still don't have x by itself. So because this is multiplying, we're going to divide. So tangent 38 degrees. So that means that x is going to equal whatever 184.5 divided by the tangent of 38 degrees is. Okay, so let's go to our graphing calculator and let's find it. So remember, as soon as we turn it on, remember the first thing we've always got to do is check our mode. So let's hit our mode here. Let's go down. Oh, it's in radian mode. Let's change it to degrees. Second quit. Okay, so let's type this in and let's find out. 184.5 divided by tangent of 38. Tangent of 38. Press enter, and we can see that, how far is she away? Well, she is 236.15 feet away. There we go. Using trig, we've solved it. Solved our first one. So let's try another one. All right, so the crossbar of a goalpost is 10 feet high, so we got 10 feet right here. Okay, if Coach Maxwell makes a field goal from 25 yards away, so I'm 25 yards away from this thing, and I clear the crossbar by 1 foot. So, in other words, well, how high did I kick this thing? Well, the crossbar's 10 feet. I kicked it 11 feet. It went 11 feet up. Okay, what is the smallest angle of elevation for which we can find? So we want to know, what is the smallest angle? Okay, well, obviously we set this up. Opposite side, this is adjacent, so it's tangent. So tangent of theta, because we don't know right now, equals 11 feet over 25 yards. Whoa, yards. Feet. Catch that one? Ooh. So let's check this one. So 25 yards times, we know there are 3 feet in a yard, so that's 75 feet. Whoa. Glad we caught that right there. So here we go. Tangent of theta equals 11 over 75. We've got a fraction, but no variable in it. So, well, I want degrees. Remember, if we want degrees, if we want to get from a decimal to degrees, we can find 11 divided by 75. If we did that, it's just some number out here. 11 divided by 75. It's just some big, long, ugly decimal. But we want degrees. We've got to use the inverse function. So second tangent, tangent to the -1 of 11 divided by 75. And we find that what is the minimum angle that I would have to kick it at? It would be 8.34 degrees. That is the smallest degree angle I could kick that at and still clear that crossbar according to that one. So, all right, so let's try another one. Sherry wants to build a ramp to jump her new RC Racer over the neighbor's 7-foot tall hedge. She wants the base of the ramp to be 5 feet from the hedge. So we know from right here to right here, this needs to be 5 feet away. Okay, the hedge is 7 feet tall. Whoa, that's one big bush right there. Okay, so we got the 7-foot tall hedge here. She wants to build it. What is the minimum angle of elevation? So she wants to know what this angle is. Well, let's look and see. We got a good drawing. 7 feet is opposite. 5 feet is tangent. In case you haven't figured out, tangent is used a ton in word problems. So tangent of theta equals 7 over 5. 7 over 5 decimal, I can do that, just like the last one. So second tangent, 7 divided by 5, and whoa! So theta is equal to 54.46 degrees. So that's the minimum angle that she could build this ramp at to go ahead and launch it over there. Okay. All right, so let's try one more. Skylar is about to dive off a cliff at Lake Catherine into an inner tube floating in the water below. Well, it sounds good. We got Skylar up here. Take it, that's Skylar. See her flowing hair and her flowing locks. Here's an inner tube floating down here in the water. Guess the water should have been blue. Sorry. So we've got that. Her brother looks through the new binoculars he got for Christmas. Well, isn't that just sweet? Probably got it from Grandma. And tells her that the angle of depression is 28.2 degrees. Angle of depression. Well, remember, horizontal lines. This down here is an angle, but that's not an angle of depression. This, some of you may want to say, hey, that's the angle of depression, it's going down. But remember, angles of elevation and depression go from a horizontal line. So here is our angle of depression right there. It is 28.2 degrees right there. And that she is 18 feet above the water surface. So she's 18 feet up in the air right here. He bets her $50 that she can't jump that far. Determine how far she has to travel through the air and if she should take that bet. Okay, well, so let's look at our triangle. Here is our triangle right there that we're looking at. Well, all I've got is this angle. I know over here is 18 feet. Well, if over here is 18 feet, then over here has to be 18 feet. Then what do they want to know? Determine how far she has to travel through the air. Well, that means she's traveling right through here. So, from her angle, this is opposite. I want the hypotenuse. Opposite and hypotenuse. Sounds like sine to me. So sine of 28.2 degrees is equal to the opposite, which is 18 feet, over the hypotenuse, which is x. So here we go. We've got a fraction here with a variable in it, so we're going to multiply both sides by the denominator, x. So we now have x times sine 28.2 equals 18. Still don't have the x by itself, so divide both sides by sine of 28.2. Since we were multiplying by 28.2, we divide to do the opposite. So x here is going to equal 18 divided by the sine of 28.2 degrees. So let's go over here and let's check. We got to do 18 divided by sine 28.2. Here we go, and find that she has to travel 38.09 feet through the air. 38.09 feet. Well, I don't know about you, but that sounds like a long ways to be turning around and jumping through the air. So I don't know. You'd have to make that call on whether she should make that bet or not. But using trig, at least we know how far she's got to go. So there we go. There is using trig, using angle of elevation, angle of depression to solve some word problems. Hopefully you got some good notes. Bring these to class with you tomorrow as long as some questions. We're going to be working a lot of these the next week or so. Have a good evening.